So in this video, we are going to be talking about non-homogeneous second order ODEs. So we have talked about ODEs that are homogeneous. That means all these sides for them, they are equal to 0 for homogeneous ODEs. Now this one, you can see all these sides are not equal to 0. Our equals to R of x is not equivalent to 0. So that means each of these equations is non-homogeneous. So what do we do when we have a situation like this? There are three ways of solving these, or there are various ways of solving. Let me say there are various ways of solving these equations. So the first thing you have to do, any non-homogeneous equation you see, the first thing you always have to do is to solve the homogeneous part of this equation. That means you have to first solve this part, take all these ones are equal to 0, then solve it to find the y complementary, the complementary solution. Then you need to find our y, our final solution equals y complementary plus our particular y, our particular solution. So you have to first find your complementary solution before you find your particular solution. The complementary solution is you solving this part as and taking this one as 0. That's the complementary solution. We all can do that one based on what we have done before. You can check previous videos for that. So this is our general solution for any non-homogeneous ODEs. So now, the methods we are going to use in solving these ODEs, we can use various methods. So I'm going to list some of the methods we can use. We are going to use this method of undetermined coefficient. Undetermined coefficient. So I call it the initial guess method. Initial guess method. For this one, initial guess method. For this one, we are just going to guess, we are going to give a guess based on our R of x, based on the function that is after the homogeneous part. We are going to try that later on. The second question, the second method we can use is the variation of parameters. Variation of parameters. This is also called the Wronskian method, but I don't really call it the Wronskian method because my own Wronskian method is quite different from the variation of parameters I use. This one I just use the formula straight away. But this one, you have to derive everything you have been doing step by step. We are going to do both two later on. And the third method we can use is called the operator D technique. Operator D technique. So these are the three ways that we use in solving non-homogeneous linear or even non-linear or whatever, or non-homogeneous second order ODEs. So these are the three methods we are going to be using in solving these three equations. So for the first one, for this one we are going to do this, and we are going to use let me see. Okay, let me write it like this. 1. Initial guess method. 2. Variation of parameters, that's Wronskian. And 3. Operator D. Operator D. So those are the three techniques we are going to be using in solving these equations. So in this video, we are just going to base on initial guess method because we have a long way to go. So the first one, let's solve the first one using. So the table we are going to be using for initial guess method, table for initial guess method or method of undetermined coefficient is that when you have your R of x, when you have a function, this R of x, what are you going to use whenever you see it? Your initial guess. Let's write it as ij. Initial guess. For anything you have like x raised power, let's say x raised power 2. Okay, let me write x raised power n, x raised power anything. So we are going to use ax raised power n plus bx raised power n minus 1, you'll be decreasing it, plus cx n raised power minus 2 till you get to z x raised power 0. X raised power 0 is the same thing as 1, so you can just remove it. So this is what you are going to use. For example, let's say we have, in this one now, we have x squared. So we are going to be using ax squared plus bx plus c. We are going to our constant. If you have x cubed, you are going to use ax cubed plus bx squared plus cx plus d, and it will continue like that. So that's the initial guess you're going to be using for polynomials like that. But if it is not a polynomial, let's say it is e raised to power x. Let's say what you have is e raised to power x. E raised to power x, you are going to just use e raised to power x. But if what you have is x e raised to power x, you are now going to use the, what is it called, this one. You are now going to turn it to ax plus b e raised to power x, and you continue it like that. And that's for that. Now for sine x Let's say you have sin x or cos x, you use the same thing for both of them. For sin x or cos x, you are going to use a sin x plus b cos x, a sin x or b cos x. That means if you see, for example, in this one now, we are going to use a sin 2x plus b cos 2x. This is if this is not in our what's it called? If it's not in our function, it's not in our complementary solution which we get when we solve this. So, for example, let's say initial guess method. For initial guess method, let's say we get two complementary solutions. C1 equals to y1 equals to, let's say this is x squared, and y2 equals to x cubed. C1 x1, C2 x3. Let's say this is the answer I get for my this. That means my initial guess cannot be ax squared plus bx plus whatever. My initial method cannot be my initial guess what's it called? Since x squared is already in this, what's it called? It's already in this solution. I have to multiply everything here through by x. So I'm going to have ax cubed plus bx squared plus cx. Now I can introduce d if you want to. You can introduce d. And this one, don't you can see this is x cubed. X cubed is already in this one too. So you still multiply again by x. So you are now going to have ax raised to power 4 plus bx cubed plus cx squared plus dx plus e. You just continue it like that. Just make sure your initial guess is not in this yc, is not in this complementary solution. For example, now let's say this one now. Let's say our y1 equals to, let's say something like x e raised to power x, and our y2 equals to what? X squared e raised to power x. Look at this, x e raised to power x is already in this. Multiply it by x, we have x squared e raised to power x. We multiply this one through by x, but it's already in this one again. You multiply again by x, so you have x cubed, and this is what you are going to use. So this x cubed that you are using, you now write it as ax cubed plus bx squared plus cx squared plus cx plus d, and this is now what you use as your initial guess method. Everything is bracket e raised to power x. Don't forget e raised to power x is here. So that's now what you use as your initial guess. And for cos x and sin x, if you already have sin 2x, let's say you already have y1 equals to c1 sin 2x, you cannot use this again. You have to multiply by x. So you are now going to use ax sin 2x plus bx cos 2x. So this is now what we are going to use as our initial guess for this equation. If and only if there is sin 2x already in the what's it called, in the complementary solution, and that's all our writing the table for. So the first one, using initial guess method, we have to solve our complementary first. We have to find our complementary solution first, or our characteristic solution. We have to find it first. So now, how do we find that? We equate this one to 0. We neglect our r of x. So we are going to have something like y double prime minus 5y prime plus 6y equals to 0. So now, solving this, we are going to have something like r squared minus 5r plus 6 equals to 0. I think minus 3 minus 2. That's r minus 3, r minus 2 equals to 0. Yeah, exactly. So it means r equals to 3 or 2. I can take this as my y1. y1 equals to c1 e raised to power 2x, and y2 equals to what? c2 e raised to power 3x. So it means my y complementary yc equals to what? My complementary y equals to c1 e raised to power 2x plus c2 e raised to power 3x. So this is the complementary solution for this equation 1, for this ODE 1. So I can write it in front of it. Complementary solution equals to what? C1 e raised to power 2x plus C2 e raised to power 3x. Now, to find our y particular, let's say our y particular equals to, from using our guess method, this is x squared, which means we are going to use ax squared plus bx plus c till we get to our constant. We are according to the constant. Ax squared plus bx plus c. So what do? We differentiate these as many times as their derivatives in this first one. What I'm saying is that we have second order, this is a second order differential equation. So we have to differentiate twice. Yp twice. Differentiate this, we have 2ax plus b. Differentiate this second time, we have just 2a. So we are going to be substituting this into our ODE. So yp, our y dot prime is 2a minus 5 into bracket. What's y prime of everything here? 2ax plus b plus 6 into bracket. What is y prime itself? Y itself, ax squared plus bx plus c. Now everything is equal to what? Is equal to x squared. We are going to include our x squared right now. So opening this bracket, we have 2a minus 10ax minus 5b plus 6ax squared plus 6bx plus 6c equals to x squared. So what do? Initial guess method, always in initial guess method you are going to be comparing. Write out every one of these parts that has x squared. It's just like correcting like terms. This is the only one that has x squared here. So 6ax squared equals to, compare here, this is the only one that has x squared, is equal to x squared. So if I divide both sides by x squared, it means 6a equals to 1. It means my a equals to what? 1 over 6. I've got it a. So what next? I compare the ones that have x. Minus 10ax plus 6bx. There's no function of x here anymore. There's no function of x here, which means it's equal to 0. So it means I can write this as I cancel out x, abi. So this means 6b equals to, if this comes to the other side, it becomes 10a. So it means b equals to 6 dividing both sides by 6, 10 over 6a. Don't forget from here we are gotten our 10 over 6 times a is 1 over 6. So this is 10 over 36. I can simplify this to 2 is what can hold. Yeah, 2. That's 5 over 18. 5 over 18. So we have gotten our a equals to what? 1 over 6. Our b equals to 5 over 18. So what do we do next? We have done the ones that have x. Now the ones that do not have any x, which are the constant terms, we have 2a minus 5b plus 6c equals to, there's no constant here, which means it's also equal to 0. So we have our a, we have our b, so we just input it. So we have 2. What is a? A is 1 over 6 minus 5. What is b? B is 5 over 18 plus 6c equals to 0. So not as to wait, what's it called? So we can now finish this up and say 2 here 1, 2 here 3. We have 1 over 3 minus 25 over 18 plus 6c equals to 0. Now 1 over 3 is the same thing as, to make it the same thing as the same denominator as 18. I can multiply both by 6. So I have 6 over 18 minus 25 over 18 plus 6c equals to 0. 6 minus 25 is minus 19. Minus 19 over 18 plus 6c equals to 0. Which means I can bring this to the other side and say 6c equals to 19 over 18. C equals to, I divide both sides by 6. 19 over 18 times 1 over 6, which equals to 19 over 18 times 6 is 60 plus 48, that's 108. 19 over 108. 19 is a prime number, it cannot go in 108. So it means my C equals to 19 over 108. And we have gotten our A, B, and C. So what do we do next? What we do next is just write our YP, our particular solution. So we are going to write our y particular. From initial one, we got yp equals to ax squared plus bx plus c. So it means yp equals to, we are gotten our a is 1 over 6. 1 over 6x squared plus what's our b? 5 over 18x plus what's our c? 19 over 18. So what do we do next? Y equals to y of c. Sorry about that. 108. Yc plus yp. So for that number one, we've gotten y equals, what's our yc? C1 e raised to power 2x plus c2 e raised to power 3x plus yp. Our yp is 1 over 6 x squared plus 5 over 18 x plus 19 over 108. And this is the final solution for the number 1 using initial guess method. And that's all about initial guess method. Let's use it to do number 2 too. Number 2 as well. Let's use the initial guess method to solve number 2. So we have y double prime plus y prime equals to 0. Let's solve the complementary part first. So this is r squared plus r equals to 0. So I can factorize this as r plus 1 equals to 0. Not to jump steps, what are we doing? First thing first, I want to find my complementary solution, my yc. So I'm going to solve this homogeneous part. That's what I'm trying to solve. The characteristic solution for this one is r squared plus r. If I input my y equals to e raised to power x, I'm going to get r squared plus r equals to 0. So I can factor r out. So it means r equals to 0 or r equals to minus 1. So it means my y1 equals to c1 e raised to power 0 x, and my y2 equals to e raised to power c2 e raised to power minus 1 x. So I can write it as y1 equals to c1 and y2 e raised to power 0 x is e raised to power 0, which is 1. So y1 equals to c1, y2 equals to c2 e raised to power minus x. So it means my y complementary equals to c1 plus c2 e minus x. So I can write it here. My yc equals to c1 plus c2 e minus x. So using the method of undetermined coefficients, using our guess method, what is our yp going to be? So our yp is going to be, there is a function of x in front. So we are going to have ax plus b. Since it's just x, so we have ax plus b. Then you write your e raised to power x. You don't need any other, what's it called here. So I can open it and say yp equals to ax e raised to power x plus b e raised to power x. I just open the bracket. So I'm differentiating twice because there is a second derivative here. The first derivative is going to give me ax e raised to power x plus, I'm differentiating this using product rule, plus a e raised to power x plus differentiating this, we have b e raised to power x, and it is okay, it's not equal to anything yet. Yp double prime equals to, I differentiate this one, so I get a e raised to power x, I'm differentiating using product rule, plus ax e raised to power x plus a e raised to power x plus b e raised to power x, right? Using product rule. So we have a raised by x, a raised by x. So this is equal to 2ae raised by x plus b raised by x plus ax e raised by x. So now we are going to include this into our ODE. Y double prime, which is 2a e raised by x plus b raised by x plus ax e raised by x plus y prime. What is our y prime? Our y prime is ax e raised by x plus a e raised by x plus b e raised by x. Compare this, we have a e raised by x here and here. This one is here, so this is 3 a e raised by x plus, for b e raised by x we have 2. 2b e raised by x plus 2ax e raised by x. Everything is equal to what? X e raised by x. X e raised by x. So we now compare coefficients. This one are a e raised by x. They are not here. X e raised by x is here. So we have 2ax e raised by x equals to x e raised by x, which means we can cancel the x e raised by x out. So we have 2a equals to 1. This gives us a equals to 1 over 2. From here, the ones that have e raised power x only, they don't exist on this side. So we have 3a e raised power x plus 2b e raised power x equals to, they don't exist here. The ones that are in terms of e raised power x equals to 0. They are equals to 0. So it means if I divide through by e raised power x, we are going to get 3a plus 2b equals to 0. But I've gotten a equals to 1 over 2 here. So it means 3 over 2, 3 times 1 over 2 plus 2b equals to 0. So this means if I'm to continue this one, I'm going to get 2b equals to minus 3 over 2. B equals to, I divide both sides by 2 times 1 over 2. That is minus 3 over 4. So I've gotten A equals to 1 over 2 and my B equals to what? Minus 3 over 4. So the final answer for this number 2 is yp equals to, since we use ax plus b, e raised to power x, so this is going to give us, what's our a? 1 over 2x plus our b is what? That's minus 3 over 4. Minus 3 over 4 into bracket e raised to power x. This is our yp. our particular y. So we are now going to add this to our yc to get our final y, our final solution. So we are going to add it to our final solution and get y equals to what? Yc plus yp. And this is equal to what's our yc? C1 plus C2 e minus x plus our yp plus 1 over 2x minus 3 over 4 into bracket 3 raised to our x. And this is our final solution for question number 2. This is our final solution for question number 2. So for question number 3, using the method of undetermined coefficients as well, continuing with our method of undetermined coefficient, we are going to solve this homogeneous part first. Y double prime plus 4y equals to 0. So this means r squared plus 4 equals to 0. Right? Yes, y is going to disappear because it's e raised to power x. So r squared plus 4 equals to 0. So this means r squared equals to what? Minus 4. Which means r equals to plus or minus square root of minus 4, which equals to plus or minus square root of, or plus or minus 2i. So we are going to have our y equals to e raised to power plus or minus 2ix. And this is going to give us y1 equals to. You can continue. You can continue. Yeah. So r equals to plus or minus square root of what? Minus 4. And this is going to give us plus or minus 2i. It's going to give plus or minus 2i, which means our y equals to e raised to power plus or minus 2ix. And we have done this before and said if we get something like this, we have our two solutions. Y1 equals to c1 cos 2x, and our y2 is going to be c2 sin 2x. If we have e raised to power aix, this is going to give a cos ax with 2 in front of the I plus b sin ax. That's the solution of any complex number, what's it called that we have. So it means our y1 equals to, and our y complementary will now be c1 cos 2x plus c2 sin 2x. So I can now write it here as c1 yc equals to c1 cos 2x plus c2 sin 2x. So we have gotten our complementary y. We have gotten our y complementary solution. So for this one now, there's one thing you have to know, please. There's one thing you have to note. Anytime you have sin 2x or cos 2x in your, what's it called, in this one here, you have to use a substitution. We have to use this substitution. Our yp equals to, instead of writing 8 is in our a sin 2x, you have to multiply it by x. Since you have sin 2x in this solution already, so you multiply this by x. So you are going to have ax sin 2x. So we are going to have our yp as ax sin 2x plus bx cos 2x. Ax sin 2x plus bx cos 2x. So our y particular is just going to be in the form of, if you have, let's say your r of x is something like cos x. Let's say your r of x is something like cos x, and this cos x is not in your yc. So what you are going to use is something like yp equals to a cos x plus b sin x. That is if it is not in your yc. If it is inside your yc, you just multiply it through by x. Multiply through by x. So since this one is inside our sin x, this sin 2x is inside our y complementary solution, we multiply everything through by x. So now let's solve this using the method we've been using before. So it means our yp prime equals to, differentiate this, we have a sin 2x using product rule, x goes first, plus 2ax cos 2x. Differentiate this using product rule, b goes b cos 2x, and since you are working with cos 2x, you want to differentiate cos 2x, minus is going to introduce, minus 2 will come out, 2bx, differentiate cos 2x, so we get sin 2x. So we have differentiated it the first time. Is there any cos 2x, sin 2x, sin 2x? So I can simplify this one to what? Sin 2x into bracket a minus 2bx plus cos 2x into bracket 2ax plus b. So this is simplified so as to make work easier for us. Now yp double prime equals to, let's differentiate this using product rule again. If you differentiate sin 2x, you get 2 cos 2x into bracket a minus 2bx plus, if you differentiate this one, we are going to get, since our a and b are the constant, we are going to get sin 2x into bracket, if we differentiate this, we have a is gone, so we are going to have minus 2b. We are going to get minus 2b. Let's differentiate the second one. Cos 2x return give us minus 2 sin 2x into bracket 2ax plus b. If we differentiate what's inside, we get plus cos 2x into bracket just 2a. So we have cos 2x, 2 cos 2x is here, cos 2x is here. So what did they ask us to do now? We are going to add y double prime plus 4y. So this means y double prime plus 4y equals to everything here, 2a, let me open the brackets, 2a cos 2x minus 2bx, 2 times 2 is 4, minus 4bx cos 2x minus 2b sin 2x, for this minus 2b, the b I'm using the b first, minus 2b, this is another minus 2b sin 2x, so this will make it minus 4b sin 2x, yes, minus 4b sin 2x plus, no, minus 4ax, I'm opening the bracket please, minus 4ax times 2, 2x times 2, minus 4ax sin 2x, sin 2x. Now this one is 2a, this is 4ax. Wait. Yes. So this is 4ax. So if I add it to this one, it's going to turn this one from 4ax to 6. Oh, this one has ax. 2, sorry, 2a cos 2x, 2a cos 2x, minus 4bx cos 2x, yes, minus 2b, okay, minus 2b sin 2x, minus 2b sin 2x, this was minus 4b sin 2x, minus 2b, okay, we have incorporated it into this one, minus 4ax, yes, minus 4ax sin 2x. Now for the last one, plus 4a plus 2ax plus 2a cos 2x, sorry, what's the 0.5? Now we are going to add 4y to it, plus 4y plus 4y. What's our y? Our y is 4ax sin 2x plus 4bx cos 2x. 4bx cos 2x plus 4bx. So this cancels out. 2a cos 2x. This 2a cos 2x. This 2a cos 2x. So this one I can write this and incorporate it into this part. Since that one is 2, this one 2 is 2, this one is 4 like this. So for sin 2x, 4ax cancels 4ax. So we have something like 4a cos 2x minus 4b sin 2x equals to 8 sin 2x is equal to our y, this y that we were using. So since there is no function of cos x in this part, it means our 4a equals to 0. Our a equals to 0. Since there is no function of cos x, everything here is cos x is 0. So we basically do not need this one from the onstart. So we have minus 4b sin 2x equals to 8 sin 2x. So we can cancel these two and say minus 4b equals to 8. So b equals to what? Minus 8 over 4, which equals to minus 2. So my b is minus 2. So working out on this, I can now say my yp equals to what? Yp equals to, since a equals to 0, everything here is useless. What about b? B is minus 2. Minus 2x cos 2x. So this is my y particular. So I'm not going to incorporate it into my y. Don't forget, y equals to yc plus yp. So our final answer is yc, which is what? C1 cos 2x plus C2 sin 2x plus my yp. My yp is minus 2x cos 2x. So since there's cos 2x here, there's cos 2x here, I can factorize it and say y equals to cos 2x into bracket c1 minus 2x plus c2 sine 2x. And that's the final answer to that ODE. And that's all about method of undetermined coefficient or initial guess method. And that brings us to the end of this video. In the next video, we are going to talk about variation of parameters. Thank you. Make sure you like, share, and subscribe.